So for this question, we're told that R is non-zero, and we want to show that the eigenvalues of RA are precisely R lambda, where lambda is an eigenvalue of A. So when it's got that precisely, basically what it's saying is that, so let's say I'm going to use a different letter, maybe mu, for an eigenvalue of RA. So, and it's pretty much just saying if and only if it's equivalent to some R lambda, where lambda is an eigenvalue of A. So what this thing is saying is that word precisely is sort of an if and only statement between the two. So what we want to establish is that the eigenvalues of RA are of the form R lambda for the eigenvalues of A, and it goes both ways. And so we want to be a little bit cautious in how we approach this, but fortunately, like everything that we do is going to be reversible. So what I'm going to do is start with the easier statement here, that lambda is an eigenvalue of A. And I'm just going to use these if and only statements to make my way to the other side. So this is by definition the same thing as saying that there is a non-zero x or a non-trivial x with ax equals lambda x. And so one thing I know is that I can just pretty much multiply both sides of that equation by r. Right, or another way I can think of it is like r times ax. Well, I know that ax is lambda x, so r times lambda x. But really, it's just taking that other equation and multiplying by r. But because we specified that r is non-zero, that means that I can reverse the equation as well. I can go from this equation up by dividing by r. I can do that because I've established that it is non-zero. So without that non-zero part, I wouldn't actually be able to make that conclusion. But fortunately, we do have that. And so I can now say there's an x that's not zero with rax equals r lambda x. And specifically, like it's the same x as I would have chosen in the other statement. And so that for us is essentially telling us that r lambda is the eigenvalue for RA, right? This is the property that we're looking for. So if I rewrite this, I'd have so this, by a definition of being an eigenvalue, tells us that R lambda is an eigenvalue of RA. And so, yeah, this is pretty much the statement. That's the mu that I was talking about above. I don't necessarily need to have it in writing, but this is our mu. And so the statement is established. So it's just a little bit of awkwardness with like what precisely means in this context. But it does mean that like the sets are identical except for that factor of R.